Section 22.2 Electron count preference. It is common to find 18 electrons surrounding the transition metal center in an octahedral complex, or 16 electrons surrounding the transition metal center in a square planar complex. But sometimes we see exceptions. For example, steric factors may restrict the number of ligands. In that case, we have fewer than 18 valence electrons surrounding the transition metal center. For example, in this transition metal complex, platinum is bonded to only 3 ligands. These 3 ligands are very bulky ligands. So this is tricyclohexyl phosphenyl ligand. And we have 3 of them. And actually there are 3 times 3, 9 cyclohexane rings surrounding this transition metal center. And that's why, due to this steric factor, this platinum is bonded to only 3 ligands. The electron configuration of a free platinum atom is 6s1, 5d9. But in the transition metal complex, the s orbital is bumped up. So you can say we have 10 d electrons. And then each ligand donates 2 electrons. So in total, we have only 16 valence electrons in this transition metal complex. Transition metal atoms or ions with very few d electrons may also be surrounded by fewer than 18 valence electrons. This is simply because we just don't have enough electrons to start with. Here's a good example. This is hexacarbonyl vanadium. This vanadium has an oxidation number of 0. Vanadium has 5 d electrons in this transition metal complex. The vanadium atom is 4s2, 3d3, so a total of 5 valence electrons. And again, in the transition metal complex, the 4d orbital is bumped up, so we'll just put this 5 electrons in the d orbitals. So again, 5 d electrons plus a total of 12 sigma electrons from the 6 ligands. So 5 plus 12, we have only 17 valence electrons surrounding this vanadium transition metal center.